So within 2 minutes, we will be starting it off. Our MCs are yet to join, so they are trying to join in.
Okay, sir, no problem, sir. Thank you.
MCs, on your go.
Doubt kills more dreams than failure ever will. With that thought, I would like to wish a good evening to all present here. On behalf of CheckDit, I, Shreya, am here with Nile to welcome you all to the 7th day of CheckDit's first ever International Research Consortium, world's first approach towards experimental growth. Let's not be afraid to try something new. Every day, try to make yourself better. Don't be afraid to make mistakes, since they are the factors of life, and it's your response to them that counts. Those who don't fail never learn anything new. Always question things about you and yourself. Ask if what you're doing now is making you better and bringing you closer to your goal. The future of research awaits us. So do not so let's get together to explore these territories. The curiosity to keep going on to uncover discovered facts of the world must always go on. We're here today to find how we can contribute more to the world of research. We're here to create a vision for tomorrow that was once only a dream. Dreams of reaching the sky is good, but the path to it's really difficult. Every success we achieve is sweet, but every failure we face should be taken even more sweetly. Here on this stage, you are free to question anything you want, since it's not the answers that enlighten us, but the questions that show us our enthusiasm. This consortium will give you an ocean of opportunities, so try to make full use of it.
Now, let's jump into right away without wasting any of your precious time. The consortium is brought to you in collaboration with ACM LNM IIT Jaipur, Heartfulness Organization, BMSC, ESAIL IIT Mandi, IEEE BMSC, Code Chef, Microsoft Innovations Club, Music Club, Dance Club, Dramatic Clubs, VIT Chennai, Skillanta, Ojashvi LPU, and Affinity Branding, along with our sponsors, Verify Motors and EduCheck. CheckDit brings you yet another magnificent opportunity to traverse the professional world. It's a mega internship program where talented young individuals who strive to bring revolution in society can be an integral part of CheckDit. Upon completion of their internship period, CheckDit has provided safe and fun learning and working experience with thousands of courses to enable team members to realize their potential. Exceptional candidates can also secure a glorious letter of recommendation and certificate of completion. You can find out more details about the Simona website, and the link is available in the chat box.
Participants, please note that certificates will only be issued if you have attended at least 10 hours of the session in the consortium. So kindly fill in the feedback form for the same at the end of each session. Now, let us meet the first speaker of the day.
Dr. Harish Kenchavanan is the professor and head of Department of Information Science and Engineering at KLA's Gokte Institute of Technology in Karnataka. He has over 14 years of experience and has guided multiple projects throughout his career and contributed a lot of his world of research. Dr. Harish also has plenty of national and international papers published. He has also been an integral part of many national as well as international conferences. We are really honored to be here, sir, and are looking forward to your invaluable words. Please take the lead from here, sir. Also note that there is a huge audience watching us live from YouTube.
Okay, thank you, Lile. It's really a great opportunity for me to discuss about recent research avenues in the Internet of Things. So in this occasion, nowadays people are really, this is going to be a kind of a buzzword, that is Internet of Things. So earlier, right, when we were studying Bachelor of Engineering in the final year, maybe in the year of 1999, we came across the word internet, that is high speed internet. So basically now we are changing into the word of, we are trying to connect the objects. Now how objects are going to communicate each other. So need some kind of a framework. Maybe we need some kind of a, you can say, kind of a infrastructure which will provide a lot of data to the researcher, or data to the maybe the promoter, data to the developer. So that data, somewhere we have to use it very effectively and efficiently, so that we can come up with a different framework of our architecture, where the objects can talk each other and it can fulfill its own requirement. With this, I will just share my PPT, and I will continue with my thought process. So the basic topic what I have chosen for discussion today is recent research trends in Internet of Things. So now if you look at the education, maybe at the primary or maybe in the secondary or even in the higher education, this particular topic is taking a very big role. And not only it is restricted to computer science, maybe it is not restricted to the information science, it is now taking in every part of the engineering stream. You go to mechanical industry, you can go to production management, you can go to the electrical engineering stream, or it may be electronics and communication. People are now talking about Internet of Things. So these are the content I have taken it. I have just divided this Internet of Things topic into three different structures. One, maybe introduction to IoT. So before going into the research domain or the maybe basic research issues in the Internet of Things, we should know the basic idea about the IoT. Then IoT protocols, IoT programming, and there may be some kind of a, you can say, the simulators, which will definitely helpful for IoT applications. This is how I have just segregated, and that is how I will be taking into the this IoT. So just if you go through the history of Internet of Things, the first thing on the internet was created in 1982. So basically, right, always if you look at whenever these concepts come across, down the line of 10 to 15 years, it will come to the market. And there is a lot of research will go into that particular concept. Not only the research, many people starts developing softwares, maybe many different frameworks, many different architectures, where people can start working on this particular thing. So similarly, that is how in 1982, some research started looking at the Internet of Things. So basically, right now, if you look at, now 27 billion, it is through some statistics, through some research, through the internet sources. So 27 billion devices are connected to data network worldwide. So basically, right, if you consider this IoT, the IoT definitely, if you consider IoT as kind of a structure or the framework, it consists of so many different electronic components. The one very important component which it is going to be connected through the internet is a sensors. So sensors are plays a very important role. The sensors role, maybe it is with respect to household appliances, or it is a machine, or wind turbines, or it may be a medical devices and cars. These are all we are experiencing day to day in many of the applications. So you may be looking at your mobile phone. Nowadays, your weight box is really connected to the your mobile app, where not only it provides a weight, it provides all the ingredients or maybe some smaller things like BMI. It provides a protein structure available in our body. Many different medical things with their statistics, you will get it in your mobile phone. That is the beauty of this basic okay basic applications of IoT. So now if you look at the basic definition of Internet of Things, the Internet of Things can be defined as a network of physical objects, or it may be a people, which we call it as a things, that are embedded with a software, electronics, network, and sensors, which allows these objects to collect the data, and maybe it will transmit it to some of the computing center, or maybe to the different objects around the network, or it maybe exchanges the data. This is how you can define the Internet of Things. So if you look at Internet of Things, or it may be like the if you consider a wireless sensor network, it is a very tiny uh, network. It is very tiny device. In that particular a small device, we require to embed associated softwares, or maybe it is going to embed some of the networking protocol into that for the exchange of the information, or maybe it is going to have some kind of architecture which is going to take you to the through a particular journey of maybe transmitting the information. So basically, right, this is Kevin Aston, inventor the term Internet of Things in 1999 only. He has said the Internet of Things is about empowering the computers so they can see, even hear, smell the world for themselves. So in the year 99 only, he has predicted that this is going to play a big role. If you look back, that is Forbes graphical structure, in 2019 it has reached to almost 20% of the your application rate of adoption in the system. That means in most of the system, you take a cars, or you take a mobile phones, or you take a maybe a fridge, or many household appliances. Most of the people are now started adopting the concept of IoT into the particular application. So this is just a history. That is what I said. In 1999, the Aston coined this particular word of Internet of Things. So if you look at the Forbes.com, it is the adoption rate as well as the growth rate is increasing exponentially. And also the organization in variety of industries, this IoT concept, they are really using it very efficiently. So that is how the business value is increasing, using this Internet of Things concept. So somewhere right in my study, or somewhere I have gone through some of the content. Now they say that these are the top 10 strategic IoT technologies and the trends which are going to play a very important role. So nowadays, right? People always, we are talking about artificial intelligence, okay, then machine learning algorithms, we have a soft computing algorithms. Those all are going to be a part of our system nowadays. You take any application, you take any, okay, system, these algorithms going to play a very important role. So whenever I look back, when we were studying in our, okay, maybe in 1999 or 2000, no, these all algorithms were there. The same searching algorithm, same sorting algorithm, then concept of artificial intelligence, or maybe if you look at the algorithmic analysis, the computing facility of our system or that in the development systems were very limited. So now if you look at the simple configuration of the computer itself will be almost similar to the server part of what we have seen in the earlier days. So because of that, the computing structure of the system is increasing. So we can definitely add these all different components into our technologies where we can make a better, you can say the facilities, better algorithmic concepts can be added to these IoT technologies. So when I say Internet of Things, definitely the data, that is whatever data it really provides, the organization can able to derive some meaningful form of it. The meaningful in the sense, maybe the inferences derived from that particular data, it may be by applying some statistical models, or maybe by doing some good fit models, or data can be used in effectively without interfering the human knowledge. So this is a one of the very important trend which is going to play a very important role in the market for a longer period. This is a first trend where IoT is going to play a role. Then trend number two, there is a maybe, okay, you have a data, you have generated the data, that data somewhere we have stored it, that stored data, the ownership of the data, who is going to take ownership of the data? Now how that ownership need to be defined for a particular Internet of Things technologies, how the privacy can be taken into consideration, how the general data protection regulation need to be defined for these particular IoT technologies. That is what the social, legal, ethical of IoT. How the data can be stored, what is the ownership you are going to own it, what is the, okay, intellectual properties we require to use it for IoT. That will be the, okay, very important aspect need to be taken care in coming days. Then the trend three will be, that is there is a possibility that I'm a car owner, no, I have such a big data related to the car, maybe to know the, okay, the lifetime of the car, I have already that particular data is available. No, I maybe want to buy it, or maybe I want to sell that particular three from the company. Now what is the strategy we will be following it in our business market? What is the strategic plan we will be considering it in our, okay, IoT technologies? That is going to be the next very important part. That is what called is as infonomics and data broking. So there is a possibility that by 2023, now we are already into the 2022, the buying and selling of IoT data will become an essential part of many IoT systems. So that is what I just gave an example. Maybe as a, okay, maybe I am a car owner. I have collected some data sets related to a particular system. No, that data, I cannot give you a freely for your inference, drawing the inference. Maybe I will be charging it. How it will be taken care in the system, that is need to be taken. One of the aspect of the your, okay, maybe strategy need to be defined for IoT technology. Similarly, the shift from intelligent edge to intelligent mesh. Now maybe, right, it is a shift from centralized and cloud to edge architecture is also maybe there is a data from one section of the things to the next section of thing, how you are going to take care. Then similarly, IoT governance, need for a governance framework that ensures appropriate behavior. So there are some of the, okay, if you look at these trends, there are at the algorithmic, there are at the level of algorithmic level where the, okay, developer can take care of this whole thing. There are some of the policies which are at the governance level where government has to interfere, and there has to be some policy decision need to be taken for these IoT related things. Similarly, right, there is going to have now, if you look at the sensors are like a toys for IoT now. You find so many different type of sensors like temperature sensor, heartbeat sensor, pulse sensor, then humidity sensor. You have so many wide variety range of sensors are going to come into picture. Then definitely there is, when you find these kind of a thing, there is going to have an innovation with respect to sensors. There may be a wide range of situations which will sensors are going to enable, and definitely the events are for every sensor, the events need to be detected. So similarly, right, when you look at this IoT component, so IoT, if you look at, it is a very smaller electronic devices which are, okay, having its own small, okay, maybe a software or hardware connected to it. Now, similarly, right, if I want to go for a deployment, there we require to have a trusted hardware. Okay, there is nowadays in every market you are getting a kind of these chipsets. But who is going to define this is a good one, this is a not a good one? It is a trustworthy, trusted hardware and the operating system, which operating system we are going to use for, okay, maybe securing the IoT system. This is a very challenging, okay, maybe the trend or the strategy we require to have it. Similarly, novel IoT user experiences. So you are define this user experience by four factors. One, new sensors. Maybe innovations are going to take place, new sensors are going to come, how it is going to be used. New algorithms are going to come, new experience architectures, context-based things, social aware experiences. These plays a very important role. So similarly, the silicon chip innovations, there may be a new special purpose chips will reduce power consumption, because this is one of the very important aspect in IoT, that is energy consumption. Now, how do we really reduce the power of a particular device? That is very important here. Then new wireless networking technologies for IoT. Nowadays, right now, we are all discussing about now 5G network. Similarly, you may come across NG network, fourth generation, okay, maybe different type of networks may come into picture. How your IoT systems are going to be plugged into these different type of networking. These are top 10, okay, strategies we need to define with respect to the IoT. So if you look at IoT application, you will find so many different architecture nowadays with the smart cities. Okay, you find so many street lights can be monitored through IoT small devices. Similarly, for home appliances, we can say Internet of Vehicles. Now, maybe those vehicles will be connected through the internet for, okay, maybe accessing some information or receiving some information. Similar to that, you find so many things, wearable devices, activity trackers, smart outlets, parking sensors, connect. So nowadays, in most of the high-end okay car, you find some sensors which will take care of your parking system. Then similarly, connecting the health. So these are the some of the consumer enterprise IoT applications. Just pictorially, I'm trying to represent it here through some of the internet resources. So similarly, helmet okay, concussion sensor. Especially this is going to be used shock box multi-sport helmet sensor. So if you get some uh, kind of a too hard hit, maybe some accident happens, by some particular mechanism, by some Bluetooth mechanism, it will send a message to a particular maybe a agency where it they will get some kind of a message saying that there is a problem with this person. No, they will take care of the system. These are all, no, nowadays we find Amazon Dash. Basically, this is a consumer goods ordering service which uses a proprietary devices. For example, for maybe detergent, uh, okay, maybe a Dash. What I can say here, Dash is a small consumer electronic device which will take care that, okay, now this is empty, need to be refilled. So automatically it will order through some mechanism and it will try to fulfill the requirement of the customer. So similarly, okay, Kinsa thermometer, it is also, so these are all small, okay, applications, smart farming. Nowadays, people are, okay, going through IoT application in a smart farming. That is even to monitor cows or to monitor the health of the plant, to monitor the, you can say, uh, the humidity of the or requirement for particular plant, even the ingredients required to grow the plant. That is all taken care by these IoT devices. Some mini projects are going on in the education sector. There are some researches are also going on in these particular things. Now, one more, okay, the very important application, what I would like to say in my research domain interest is water quality monitoring. That is one of the very important issue. Especially this is the project taken it by the Department of Science and Technology. They call it as, okay, water technology or water quality monitoring technology, where they want to, okay, minimize the interference of the human being. Maybe the system itself should take care and it should do some changes where it can taken into the drinkable water. I think maybe you have seen in the Ganga Jal, okay, there is a lot, the pollution is so much. You cannot really use that water, drinking water, and we always, okay, do a puja with respect to Ganga water. That is the, okay, kind of a things are now coming up with respect to IoT applications. So these are the right some of the application which we always look into and we try to associate with the Internet of Things. Okay. Now, right, I'm just listed out here, lot of, okay, research challenges are there. There are a lot of research issues are already available. There are many different, okay, researchers, they are working on some of the aspects here. Now, if you look at IoT is not a, okay, new thing according to me, but the people have, okay, tried to, okay, define the internet in a some different way. Now, internet require lot of, right, big resources, like maybe I can say lot of, maybe memory consumption will be there. Energy is one of the aspect. Then definitely, right, you need a lot of resources. You require a bigger devices. Nowadays, you definitely can access internet through a smaller device. But earlier, if you look at, okay, these are the resource, okay, are enormous with respect to internet. But if I look at IoT, it is a tiny, okay, devices. Maybe we would like to reduce the size of the device, and that smaller device should work like your computer. That is what the author of the Internet of Things, he wanted to mention it here. So IoT, it's a resource constraint device. What I mean to say here, in a smaller device with a smaller memory capacity, with a smaller energy or the power supply, we should try to get more, okay, applications. should, application should be solved. Those are the challenges I have listed out here. One of the very important challenge in Internet of Things is security, privacy, and trust architectures. So I think just now I just given you the trends in IoT. Similar to that, big data analysis. No, the data need to be the analysis, because definitely right, if I look at the Internet of Things, the data generated per second will be enormous. Okay, it is maybe in terms of, okay, GB data you find it in that, the very valuable data you are going to use it, and that need to be used for some inferences. Similarly, device interoperability and compliance. So definitely you find so many variety of devices, so many different variety of softwares, so many, okay, constraints in that. So how you are going to build an interface so that we can take care of that particular thing in the development. Similarly, robustness, fault tolerance, okay, cognitive networking. You have a knowledge base. Those knowledge base, how can I use it in my the energy aware approaches? That is, how can I conserve the energy, and that energy factor also need to be taken care in the, okay, wireless sensor network as well as IoT system. So like that, these are the some of the research domains. Similarly, the mobility, how can you are going to define the mobility, reliability, then scalability, programmability, how I can really program the, okay, that particular component of software and the devices, and how can I use it in my computer network, or how can I use it in the exchanging the information. Because if you look at the IoT, okay, there are IoT communication models are available. The one very important, very traditional IoT model or the communication model is client request model, or client server model, or request response model, I can say. There is one more model available is publish and subscribe. Similarly, push and pull. Like that, you have so many models. How those models you are going to use it in your application, and how best efficiently you can, okay, fulfill these challenges. That is going to play a very important role. Then addressability, because nowadays, now in our internet scenario, the most of the cases we have worked with IPv6, but already IPv6, sorry, IPv4, but now, right, IPv6 is taking a big role looking at the IoT applications. So these are the some of the, okay, then there may be an integration with AI and automation. So that is the first trend in the Internet of Things, that is artificial intelligence algorithms, or maybe a machine learning algorithms. How best statistical models you are going to embed into the automation, so that there is no need to have a separate architecture for intelligence system and the networking, how we can combine it. These are all different challenges you come across with respect to the, okay, IoT or Internet of Things. So similarly, the IoT network design and architecture, this is one of the very important area. Okay, IoT, basically, right, there is no fixed architecture as such you are available right now, but still, no, based on the application, people they come with these, okay, different architecture and different protocol they use it, and try to establish the or fulfill the that particular application. That is how, okay, people are working on it now. So similarly, right, IoT enabled software architectures. Okay, what will be the middleware? How you are going to define it? That is IoT based data acquisition, knowledge management, semantics. Then how you are going to model these things? Similarly, context aware and location aware. Okay, related issues. Context awareness in cloud and IoT, then definitely context aware models and protocols. Similarly, security, privacy, and trust. Now, how IoT and cloud security you are going to combine it? What are the privacy issues? Authentication, how you are going to define it? Now, these trust management concepts, these are all okay. If you look at IoT itself is not a one separate area. It is okay add-on area with many different, you can say, the layers above that. One, maybe it is going to capture the information. After that, how you are going to use that captured data with a proper algorithmic design to get a good inferences, so that the inferences can be again revisited into IoT system, and that can be used in our application. That is how you are going to use these things. Now these are the some of the if you look at your TCP IP protocol stack, okay, this is a one traditional TCP IP protocol stack. Similarly, right, now if you look at the protocol stack, so the requirement with the best protocol at every layer is not possible. So definitely the proper group of protocol at each layer is must for desired efficiency. The same, the traditional internet protocol stack is not suitable for IoT communication because of overhead and the complexities. Otherwise, definitely it will lose its energy if you have more control messages system, or if you have a more overhead, it leads to so many other problems. So this is a typical IoT protocol stack, which maybe in our Internet of Things application it uses, especially that message queuing, telemetry transport protocol, constraint application protocol, advanced message queuing protocol. Like that, we have so many different application layer. But definitely, if you look at, no, it is going to use some inherited feature of TCP/IP protocol. Now, the meaning here it is, they have, maybe created, lightweight version of the transmission control protocol and user datagram protocol, and that is going to be used, with the IoT protocol stack. So these are the some of the protocols I have listed out with respect to Internet of Things. The first data link protocols, where you have IEEE 802.15.4e. Similarly, Zigbee, many people they use it. Even LoRaWAN, LTE, all these are the data link protocols. Similarly, network layer routing protocol, that is reduced RPL protocol. Then similarly, network layer encapsulation protocols like IPv6 over Bluetooth, low energy, IPv6, 6LoWPAN, transport layer protocol, TCP, UDP. Just now I sold light version of TCP and UDP it uses. Then similarly, the application layer protocol, MQTT or SMQT, then constraint access control protocol. So like that, it uses some different protocol. So this is how I can say define IPv6 for Internet of Things is using it. That is IPv6, wireless sensor network, 6LoWPAN. Then now we are looking at Internet of Things. So this is one of the case study for IPv6 over low power wireless personal area network. It is going to use 128 bit of address. So this is the 6LoWPAN stack. If you look at this, just now we discussed about IEEE 802.15.4. Similarly, it has its own IPv adoption layer, then UDP, ICMP. Now, if you look at compare with the TCP/IP protocol, so I'll just skip these it is a information related to different layers of your IoT protocol stack, which already I have covered in some of the discussion. UDP, these are one of the constraint application protocol, COAP. Now, I would like to highlight this one protocol which is playing a big role in the Internet of Things networking. This is called as routing protocol for low power lossy network. Basically, this kind of a RPL protocol works on the basis of okay graph. Okay, these are the right, some different nodes are available with respect to Internet of Things, where it will try to form the okay graph, and for every, you can say, node, you have some well defined objective functions. So there are some, okay, if you look at other, this is a DODAG route, information salutation. Then similarly, DODAG information object, destination advertisement. Like how in our traditional networking, we had so many different routing algorithms, Dijkstra's algorithm or distance vector algorithm. Similarly, now in Internet of Things, we have one okay routing protocol which is taking a big role in the IoT, is called as RPL, and it works on objective function. Similarly, there is a one more okay transfer protocol, that is constraint application protocol, which we call it as COAP. That is, COAP is a transfer protocol for a constraint nodes and networks. So basically, it uses the concept of okay communication by exchanging a representation of these resources using transfer protocol such as HTTP. It uses based on the HTTP request response based model. Okay. Yeah. So this is the protocol stack. Okay, that is what we have discussed. These are the different transfer protocol. The next one is IoT programming. Okay, if you look at the IoT application, various tools called IoT programming, then IoT definitely we require to analyze IoT network and protocol. It is essential. If you take any kind of a concept, that concept need to be okay conceptualized. Know how you are going to do it. Maybe there are two ways to do that. One, you are going to have your own hardware protocol stack. Okay, maybe you are going to write some program onto those okay hardware, and you are going to check it in a real world. Or maybe there is going to have a kind of a simulator or emulator. The simulator is a one which we try to imbibe the realities through some mathematical model, which okay people can recognize it. Okay, these are all very important aspect in our okay maybe performance analysis. So these are the right, some of the programming paradigm suited for IoT is functional data flow. It helps to solve the challenges of scalability and concurrency. Then it emphasizes the movement of data. Data flow languages are inherently parallel, can work well in the large centralized system. Then it is maybe event driven. Okay, most of the cases, definitely it is considered to be a kind of a discrete event systems. So in that discrete event system, okay, how those different events are going to be scheduled with respect to the time, with respect to the events triggered by the sensors, connectivity, time, that all need to be taken into the consideration. And accordingly, you will be okay trying to do some kind of a simulation in the considering all the aspect of the system. That is very important in our system. So for to justify this particular thing, we have a concept called as, so basically these are all different type of systems are available here. One, that is Eclipse IoT projects, Arduino IDE, where it supports C++ programming, Raspberry Pi, Open SCADA, embedded OS like TinyOS, RTOS, Contiki OS. So these are the right different simulators which we can use it for IoT programming. So I'm just giving you one a slide where people can people are really working with these different architecture, free and open source tools for IoT programming. There is a one okay, software called as Open IoT. Then we have Jetta distributed services architecture, then Node Red, then IoTVT. So like that, you find so many different uh, platforms where people can work with those different modes and then try to find out the efficiency of every protocol, and then accordingly you can try to define it. So already we have gone through these different so these are the some of the pictorial representation of hardware for IoT. Maybe many people may be working on these hardware open kits. So I'll not be going through these all case studies. So there is a one more, I will take some 2-3 minutes to explain you this. Then Contiki is a one of the very open source tool which we people can really install it and work with different IoT layer protocols. Okay, definitely right. It has its own embedded system. Even in the a simulator in the environment, you can really use this Contiki operating system. So basically, the Contiki operating system is a small, tiny operating system which will support the functionalities of all the sensors, which you can use it for your protocol. You can write small protocol. There is a built-in system which we can use it with the Contiki is CUSA simulator, which you can use it for this Contiki OS. So this is a small architecture how you can use it your IoT system with the Contiki OS. So I'll just list out some of the functionalities of the Contiki. It's a kernel function, event-driven kernel. Multi-threading is supported by application. Supports dynamically loadable and programmable services. Especially it provides the kernel by posting events. Then kernel allows device drivers and application to directly communicate with the hardware. So this is how your Contiki OS looks like. This is a kernel, program loader, language runtime, communication service. So this is a different services available in Contiki OS. So basically, right, sensor network programming has two important part. One is node centric and another one is application centric. So basically the node or the application centric focuses on the software for the nodes or per node level. Then application centric focuses on the software for part or all the network as one entity. So maybe right in your Contiki operating system with the CUSA simulator, it provides these kind of components are available. So people can take that component and they can start working on their own algorithm, their own aspect. And this is that aspects can be used for improving the IoT, the performance. So that is how this Contiki operating system with a CUSA simulator can be used in the IoT protocol design. So with this, right, I thought these are the content of my discussion. That is how I started with the introduction to the some of the aspect of IoT programming. Yeah, thank you very much for giving me this opportunity, for giving me the some of the insight about what all the things are happening in the Internet of Things. And maybe I'd done a justice to this consortium. Yeah, thank you everyone.
Thank you so much for such an incredible session, sir. I'm sure everyone thoroughly enjoyed. It was really relatable and so informative. Thank you so much for your valuable insights. If anyone from the audience has any queries, you may drop them in the chat.
So I have one query. Shreya, may I?
Yeah, Asha, please.
What do you see that how an integration between these three major technologies like blockchain, AI, and IoT? What are the applications of these particular technologies, sir, in your opinion, and with your experience?
No, basically, I have not really right person to talk about the blockchain, but definitely I can look into AI and Internet of Things. It is really going to play a big role. So AI is nothing but right. It's a artificial intelligence where definitely it works on the data. Okay, basically the whatever data collected through some of the medias or some through the experiences or maybe through some of the whatever social experiences you have, that data can be used and fed into the artificial intelligence algorithms, and maybe that is going to take care of its okay requirement of the system automatically without the knowledge of you, that can be done through the system itself. That is possible. So that is how you can definitely integrate okay the IoT and the artificial intelligence algorithms. Because now one more thing right we can look into is the IoT components or the hardware devices available can definitely can okay embed the artificial intelligence algorithm into the system, and it can take care of itself. Yeah, I think I have done your I convinced your question.
Yes, yes, definitely. So I have another following question to that, sir. And how do
Yeah.
you think that we can ensure that particular level of security? And what are the security measures we should keep in mind while developing any IoT solution? Because when
Yeah,
it comes to data
definitely.
and IoT, and if everything's automated, there are high chances of it to be get hacked and get manipulated. So
I really agree with you. Okay, I think right in my discussion, I have taken that as a one of the challenge. Okay, the trend. There has to be. I can give you one small example nowadays. I think in the digital world nowadays. Okay, earlier right people from the rural area or maybe from the maybe mid urban areas, they never thought of using these credit cards or debit cards regularly. No, maybe it is really very urgent, they used to go for it. But nowadays, if you look at even rural area, people started using the debit card and credit card. So there is still we have some security lapses, but still people are started using it slowly. So similar, maybe the policies has to be okay taken into consideration. Maybe our technology still has to grow. Okay, those all security feature need to be taken care by at all different level. Then only these systems are going to come as a full fledged. This is what my thought process for your question.
I
Yeah,
got it. Thank you
thank
very
you.
much, sir. Over to you, Shreya.
Yeah.
Uh, Thank you so much, sir, for clarifying our doubts. Now, I would like to call upon Saharsh for the word of thanks. Over to you, Saharsh.
Thank you very much, Shreya. Thank you, Arish, sir, Dr. Arish, for
Thank you.
amazing session and great insights what you brought on the table regarding IoT, how it can become a game changer in the upcoming scenarios, and how we can develop on these particular scenes. So extremely thankful to you, sir, your amazing session and taking out time out of your busy schedule, sir. So thank you very much for accepting our offer, for accepting our invitation to be a speaker for the day 8. Today's day 8, sir, final day for the International Research Consortium. So thank you very much, sir. Thank you. And I will request my team to please share the memento of gratitude to our esteemed speaker, Dr. Harish.
Thank you, Saharsh, and giving me this opportunity. Thank you.
Sir, please accept our heartfelt gratitude, which we wanted to present to you. Thank you very much, sir, for agreeing being our speaker and being here for us, taking out time on the Monday. I can understand how Monday can be a hectic schedule for anyone, but still you taken out time and you are here with us. Thank you very much. And please accept our heartfelt gratitude token. I will also like to thank Dr. Rajeshwari Hegde and Dr. Susan, because without these two mentors, mentorship and guidance, we would not have achieved this much. So thank you very much, ma'am. I will also like to thank our sponsors, Verivo Motors and EduCheck, for their amazing faith in us and allowing us to do what we wanted to. And each and every collaborator, each and every organizing committee who supported us in our venture. Thank you very much to everyone, and stay tuned for another exciting session by Dr. Vijay Lakshmi. And she will be guiding us through the brain signature analysis. Amazing topic, amazing insights, and amazing work. So stay tuned for that. And thank you very much. Within 2 minutes, we will be starting our next session. Thank you.